In this video, we will discuss collecting sampling data. An important note, if sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. Randomization with placebo or treatment groups is sometimes called the gold standard because it is so effective. In 1954, an experiment was designed to test the effectiveness of the Salk vaccine in preventing polio. By random selection, 401,974 children were randomly assigned to two groups. The first group was 200,745 children who were given a treatment consisting of Salk vaccine injections. The second group was 201,229 children who were injected with a placebo that contained no drug. Among the children given the Salk vaccine, 33 later developed paralytic polio. And among the children given a placebo, 115 later developed paralytic polio. The previous example describes an experiment because subjects were given a treatment, but ethical, cost, time, and other considerations sometimes prohibit the use of an experiment. We would never want to conduct a driving texting experiment in which we ask subjects to text while driving. Some of them could die. It would be far better to observe past crash results to understand the effects of driving while texting. In an experiment, we apply some treatment and then proceed to observe its effect on the individual. The individuals in experiments are called experimental units, and they are often called subjects when they are people. In an observational study, we observe and measure specific characteristics, but we don't attempt to modify the individuals being studied. Experiments are often better than observational studies because well-planned experiments typically reduce the chance of having the results affected by some variable that is not part of a study. A lurking variable is one that affects the variables included in the study. In an observational study, we might observe past data to conclude that ice cream causes drownings based on data showing that increases in ice cream sales are associated with increases in drownings. The mistake is to miss the lurking variable of temperature and the failure to see that as temperature increases, ice cream sales increase and drownings increase because more people swim. We might instead conduct an experiment with one group treated with ice cream while another group gets no ice cream. We would see that the rate of drowning victims is about the same in both groups, so ice cream consumption has no effect on drownings. Here, the experiment is clearly better than the observational study. Good design of experiments includes replication, blinding, and randomization. Replication is the repetition of an experiment on more than one individual. Good use of replication requires sample sizes that are large enough so that we can see the effects of treatments. In the Salk experiment, the experiment used sufficiently large sample sizes so the researchers could see that the Salk vaccine was effective. Blinding is used when the subject doesn't know whether he or she is receiving a treatment or placebo. Blinding is a way to get around the placebo effect, which occurs when an untreated subject reports an improvement in symptoms. The Salk experiment was double-blind, which means that blinding occurred at two levels. The children being injected didn't know whether they were getting the vaccine or a placebo, and the doctors who gave the injections and evaluated the results didn't know either. Codes were used so that the researchers could objectively evaluate the effectiveness of the vaccine. Randomization is used when individuals are assigned to different groups through a process of random selection, as in the Salk vaccine experiment. The logic behind randomization is to use chance as a way to create two groups that are similar. A simple random sample of n subjects is selected in such a way that every possible sample of the same size n has the same chance of being chosen. Throughout the class, we will use different statistical procedures, and we will often have a requirement that we have collected a simple random sample as defined above. Other sampling methods. In addition to simple random sampling, here are some sampling methods commonly used for surveys. A systematic sample just selects every kth subject. A convenient sample just uses data that are very easy to get. A stratified sample subdivides population into strata, or groups, with the same characteristics, then randomly samples within those strata. A cluster sample partitions the population in clusters, again, groups, then randomly selects some clusters, and then selects all members of the selected clusters. Professional pollsters and government researchers often collect data by using some combination of the preceding sampling methods. In a multi-stage sample design, pollsters select a sample in different stages, and each stage might use different methods of sampling. The US government's unemployment statistics are based on surveys of households. It is impractical to personally survey each household in a simple random sample because they would be scattered all over the country. Instead, the US Census Bureau and the Bureau of Labor Statistics collaborate to conduct a survey called the Current Population Survey. A recent survey incorporates a multi-stage sample design, roughly following the steps in the next slide. First, the entire United States is partitioned into 2007 different regions called primary sampling units, or PSUs. PSUs are metropolitan areas, large counties, or combinations of smaller counties. The 2007 PSUs are then grouped into 824 different strata. In each of the 824 different strata, one of the PSUs is selected so that the probability of selection is proportional to the size of the population in each PSU. In each of the 824 selected PSUs, census data are used to identify a census enumeration district, with each containing about 300 households. Enumeration districts are then randomly selected. In each of the selected enumeration districts, clusters of about 4 addresses, contiguous whenever possible, are randomly selected. A responsible person in each of the 60,000 selected households is interviewed about the employment status of each household member of age 16 or older. This multi-stage sample design includes a combination of random, stratified, and cluster sampling at different stages. The end result is a very complicated sampling design, but it is much more practical, less expensive, and faster than using a simpler design, such as a simple random sample. Observational studies. The following definitions identify the standard terminology in professional journals of observational studies. In a cross-sectional study, data are observed, measured, and collected at one point in time, not over a period of time. In a retrospective study, data are collected from a past time period by going back in time, through examination of records, interviews, and so on. In a prospective or longitudinal or cohort study, data are collected in the future from groups that share common factors. Such groups are called cohorts. In an experiment, confounding occurs when we can see some effect, but we can't identify the specific factor that caused it, as in the ice cream and drowning observational study. The Salk vaccine experiment illustrates one method for controlling the effect of the treatment variable. Use a completely randomized experimental design whereby randomness is used to assign subjects to the treatment group and the placebo group. A completely randomized experimental design is one of the following methods that are used to control effects of variables. Completely randomized experimental design means to assign subjects to different treatment groups through a process of random selection. Randomized block design. A block is a group of subjects that are similar, but blocks differ in ways that might affect the outcome of the experiment. The following procedure is used. First, form blocks of subjects with similar characteristics, and second, randomly assign treatments to the subjects within each block. Matched pairs design. Compare two treatment groups, such as a treatment and placebo, by using subjects matched in pairs that are somehow related or have similar characteristics. Rigorously controlled design. Carefully assign subjects to different treatment groups so that those given each treatment are similar in the ways that are important to the experiment. This can be extremely difficult to implement, and often we can never be sure that we have accounted for all of the relevant factors. Sampling errors. Definitions. A sampling error, or random sampling error, occurs when the sample has been selected with a random method, but there is a discrepancy between a sample result and the true population result, such as an error resulting from chance sample fluctuations. A non-sampling error is the result of human error, including such factors as wrong data entries, computing errors, questions with biased wording, false data provided by respondents, forming biased conclusions, or applying statistical methods that are not appropriate for the circumstances. A non-random sampling error is the result of using a sampling method that is not random, such as using a convenience sample or a voluntary response sample.